All right, today we'll be talking about the commutative property. Here, let me write that for you. Commutative property. All right, this is a property of math, and if we look at commutative, it has commute in it. And a lot of you might have heard maybe your parents talking about having to commute to work. Commute means to travel or to move. So the commutative property is a property in math that talks about moving numbers around. And this property, it can be used for addition and for multiplication. So if we talk about, we'll do addition first. The addition commutative property is saying that you can do 5 plus 3 equals 8. And it says that then you can also move those around, and you can say that 3 plus 5 equals 8. And no matter which way you move numbers, if you say, one number first or the second number first, they still add up to the same thing. You can do that with anything, adding it. I could change that. I could say 100 plus 50 equals 150, or I could say 50 plus 100 equals 150. Either way, no matter which way I add them, I come up to the same thing. And you can do it with more than two numbers. It doesn't matter how many you have. 1 plus 3 plus 7 plus 8. Let's see. 4 plus 8 is 12, plus 7 makes 19. Or you could say 7 plus 3 plus 8 plus 1. It's still going to be 10, 19. Or you could do, let's see, 3 plus 8 plus 1 plus 7. Let's see, 8 plus 1 is 9, 7 plus 3 is 10. It's still 19. So I can move them around in any order I want to. And this works also for multiplication. Multiplication. It works for multiplication as well. I can say 7 times 8 equals 56. And I can move that around and say 8 times 7 equals 56. It doesn't matter which order I write it in. I get the same answer at the end of it. I could do 4 times 9 equals 36, or 9 times 4 equals 36. Same answer. And I can also do this with multiple numbers, just like I did with the addition. So if I wanted to put 3 times 2 times 4, let's see, 3 times 2 is 6, 6 times 4 is 24. Or I could write 4 times 3 times 2. Let's see, 4 times 3 is 12, and 12 times 2 is 24. Or I could write 2 times 4 times 3. Well, let's see, 2 times 4 is 8, and 8 times 3 is 24. So I get the same answer. The commutative property, however, does not work for subtraction, and it does not work for division. If I move things around when I divide or when I subtract, I'm going to get a different answer. So let's look at subtraction really quick. Subtraction. If I do 10 minus 3, I get 7, correct? However, if I do 3 minus 10, I'm going to have a negative number. I'm going to have negative 7, and those two are very different numbers. If I'm on a number line here, here's 0, 7, let's see if you can see this really quick. 7 is all the way up here. 1, 2, 3, 4, 5, 6, 7, like I have like 7 cookies, for instance. However, negative 7, that's on the other side of 0. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and negative 7. This is like saying I don't have enough money, I'll have to borrow from somebody, so I owe them money. You can see they're 14 apart, because I've got to go 7 to get from just 7 to 0. and another 7 to get from 0 to negative 7. So that's a total of 14 very different numbers. So 10 minus 3, one number, 3 minus 10, a totally different number. The commutative property does not work for subtraction. It also, like I said earlier, does not work for division. If I do 56 divided by 8, I get 7. However, if I were to write 8 divided by 56, would I get 7 in that case? I'm going to say no, right? Let's see, what is 8 divided by 56? That would be 8 on the inside and 56 on the outside. Well, I have to put my decimal here. I'd be getting something less than 1, like 0.1 something, 1/10. So two very different answers also. One is a whole number and one less than 1. So the commutative property, again, you can move numbers around when you add and when you multiply. However, when you subtract and divide, you have to do it in the order that they give it to you.